Okay.
Okay, here we go. First lesson in trigonometry. And what's great about trigonometry is that in similar right triangles, the ratio of the sides remains the same regardless of the size of the triangles. And we've seen that a lot with similarity when we have similar triangles. For example, a 45, 45, 90 that's small in size as compared to one that's big in size, still are similar. The definition of the trigonometric functions is based on this idea. So, the sine of an angle, we're using the Greek letter theta for that, the sine of an angle is equal to the ratio of its opposite leg over the hypotenuse in any triangle. The cosine of the angle is equal to the adjacent leg over the hypotenuse. So, when I'm saying the opposite leg, let's look at this little triangle here, the 3, 4, 5 triangle. If I'm saying the leg that's opposite the angle A here, that would be the 4. Okay. If I said adjacent to this angle, well, it's not the hypotenuse, it's the other side, the other leg that's basically adjacent or part of, makes up part of this angle, so it would be the 3. Tangent of the angle is the opposite leg over the adjacent. So if I wanted to find the tangent of angle A, it would be the opposite, which is 4, over the adjacent, which is 3. Okay. Easy way to remember this is SOHCAHTOA. S-O-H-C-A-H-T-O-A. Very catchy, SOHCAHTOA. All right. So, if I asked you in the big triangle to find the sine, that would be opposite over hypotenuse. In the big triangle, the opposite would be 12. The hypotenuse would be 15. 5 plus 5 plus 5. So it would be 12 over 15, which reduces to your honors geometry brainiacs. You can figure that out yourself. Okay, so we're going to go ahead and try some of these here. And I think you'll find this very helpful. So you can notice what kind of triangle this is. It's one you're very, very familiar with, the 30, 60, 90 triangle. And I'm telling you that the side opposite the 30 is 1. So what's the side opposite the 60? Of course, root 3. What's the hypotenuse? It's double 30 sides, so obviously it's a 2. You guys are all well aware of that. Okay? And a 45, 45, 90. If I tell you that one of the sides opposite the 40, one of the 45s is 1, the other one obviously is 1, and the hypotenuse is root 2. Okay. So what I want you to do now is to fill in the chart below with the trigonometric values of these special angles. Okay? So for these triangles, I want you to figure out the sine, the cosine, and the tangent of the 30 degree, the 60 degree, which obviously you'll use this triangle for, and then the 45 degree. We'll start doing one together, and then I want you to go ahead and pause, and then, not you, Caroline, you keep it running. They'll pause as they're watching it, and try filling in the rest of them, and then we'll go over them. But let's go ahead and do the 30 in terms of the sine. Here's my 30 degree angle. This is the one I'm using. So its sine is SOHCAHTOA, so it's opposite over hypotenuse. So the opposite here would be 1. The hypotenuse obviously is 2. So what's my sine of my 30 degree angle? It's 1 over 2. Okay, go ahead and pause. Do cosine and tangent for 30 right now. Okay, we're back. And the cosine, hopefully you got root 3 over 2. Adjacent to the 30 over the hypotenuse. And for the tangent, it's TOA, opposite over adjacent. So it would be, again, 1 over root 3, which obviously equals root 3 over 3. Simple rad form. Right, Caroline? Yes. Okay. Go ahead and try the 60 now. And we're back. Sine for the 60, you should have gotten root 3 over 2, right? Here's the 60, so its sine is opposite, which would be root 3, over the hypotenuse, which is 2. Okay? Cosine is 1/2. Now we're working with this angle, so it's adjacent over hypotenuse. and you should have gotten root 3 for the tangent. Opposite over adjacent, root 3. Okay, go ahead and try the 45 now. Okay, sine, by the way, does it really matter which 45-degree angle I choose? Of course not. It's going to be 1 over root 2 to start, which simplifies to root 2 over 2. Then we, also for the cosine, it's going to be the same thing. And the tangent is 1. Because if I'm using this as my 45-degree angle, it would be opposite over adjacent. If I use that one, it would be opposite over adjacent. Okay. Some examples to try. What I'd like you to do is I'd like you to try them, and then, or pause, try it, and then go ahead and play the explanation they'll give, and hopefully they match. So, I want you to find the sine, cosine, tangent of angle A. Okay? Notice I put a star there to kind of give me a good reference of what angle I'm talking about. So, go ahead and try the problem now. If AC is 4 and AB is 10, I wonder what BC would be. Okay, well, you might have to figure that out. But go ahead and try it. All right, we're back. And so you probably figured out that the length of BC was 2 root 21. And this would be the opposite side. This would be the hypotenuse. Obviously, this side right here is the adjacent if I'm talking about that angle. So, I think right here is how I figured out that I got the 2 root 21. Pythagorean. So the sine of angle A would be opposite over hypotenuse, so it would be 2 root 21 all over 10. Can reduce the 2 and the 10 to root 21 over 5. Cosine of angle A, hopefully you got 2 over 5. 4 over 10 reduces to 2 over 5. And for tangent, opposite over adjacent, you would have had 2 root 21 over 4, which reduces to root 21 all over 2. Okay. So, we're going to talk about how I arrived at this. The measure of angle A approximately equal to 66, and the measure of angle B approximately equal to 24. I'm going to go off the camera for a second, keep it running there, Caroline, and I'm going to grab my textbook, and I believe I've given you this page already, and I should have had this ready to begin with, but I didn't, unfortunately. But there's actually a chart in the back of your book. It's called a trigonometric chart of values, and I'm having some difficulty finding it. Hi. Why don't you go ahead and pause it? Ms. Savage is here for a brief interview.
I'm subbing for Mark Schul, 2 doors down, and I have a DVD to show, and I'm pushing play on all the machines and it won't play. Do you have any idea how to make that?
Okay, so while we were trying to help Ms. Savage play a DVD in the other room, I was able to locate the trigonometric table of ratios, which is on page 567, and I think I've given that to you already. If not, I should have. But anyway, the way that works is, if, for example, I know the cosine of angle A is 2 over 5, which is 0.4, you actually go in the table, and you look under cosine, and you look down and you look for the closest value to 0.4, which is actually 0.407, and that, if you look across, that says 66 degrees. So that tells you that angle A is approximately 66 degrees. How do I get angle B? I don't have to use the table for that. I just subtract 66 from 90, because we're talking right triangles here. So the two non-right triangles, obviously, are complementary and add up to 90. So 90 minus 66 is 24. So if I need to find the sine, cosine, tangent of angle R here, well, okay, let's figure out what the hypotenuse is. It's 6 root 5. That's my adjacent side if I'm talking about angle R. This is my opposite side if I'm talking about angle R. Go ahead and try and figure out what the sine, cosine, and tangent are of angle R. Okay, we're back. So the sine of angle R, hopefully you got 2 root 5 over 5. Cosine of angle R, hopefully you got angle 5 over 5. And the tangent of angle R, hopefully you simplified it to 2. Okay, so how do we figure out what the measures of angle R and angle S are? Okay, well let's take one and use our table. It's right here again, page 567. Let's take the tangent of R. So I'm going to look for a value of 2 under the tangent column, and that looks like it is closest to 63. It's right between 63 and 64. So let's see. Yeah, I went with 63. I think it is slightly closer to 63. 63 is 1.963. 65 was 2.050. So it is a little closer to 63. So we'll use 63, which means that S is 90 minus 63, or 27. Okay, and that does it. You'll have read 17.1, you'll have watched this video, and you've completed your homework now. Tomorrow you'll come into class and we'll do some problems out of the book and go from there. Thanks, Caroline. Appreciate your help.